Hi everyone. There are some advanced SQL features beyond just group by which not only simplify data analysis but can also help us take a small step towards becoming a better data engineer. In this video, we will be discussing advanced SQL aggregations using grouping sets, cube and rollup, and you will see how easy it is to apply these new concepts in your day-to-day work. So please stay tuned. Let's walk through our agenda. We will start with the problem statement to understand why advanced group by features are crucial. Then we will deep dive into grouping sets, cube and rollup with a practical example using an end-to-end demo. So without further ado, let's get started. To fully appreciate the power of advanced SQL features, we first need to understand the limitation of the group by clause, which includes that you can only group by a fixed number of columns at a time. And if you have a use case where you need to get aggregations based on different combination of columns, the query becomes long and repetitive. To make things worse, the query will be very slower because it has to scan the underlying table multiple times. In the demo, you will see how these new features effortlessly overcome the shortcomings of the group by clause. In this slide, we are going to discuss three subclauses of group by, which are grouping sets, cube and rollup. In grouping set, we can specify multiple groupings in a single query. For example, if you have three columns, A, B, C, and you have some requirements to have some combinations of columns. So based on your requirement, you can specify in your grouping sets and generate the output accordingly. Cube is very simple. It generates all the combinations of the specified columns. For example, if you have A, B, C as three columns, so it will generate all the 8 combinations for your aggregation. Rollup is a bit different. It generates a result set and shows aggregation for each hierarchy of the specified column. If we have three columns like A, B, C, where C is most granular, and if you apply rollup on A, B, C, we'll generate 4 combinations of aggregations, which are A, B, C, A, B, A, and none. Let's see all these concepts in more detail in our demo shortly. Let's create a table, product, sales. This table has columns like country, state, city, store, and then product, sales date, and sales amount. So if I query this table, it will be empty. So let's insert some data into this table. So this is an insert script where I have created some dummy data and I will insert into this table. Cool. Around 15 records has been inserted. Let's query this table again. And we can see data for different countries, states and cities and stores having with different products, and sales date has some sales value. Let's consider a scenario where country equal to USA and we want to do our data analysis based on state and city, and the requirement is to have different combinations of aggregations based on these 2 columns. So the combinations could be state, city, and then it could be just state, and then aggregation could be at city level, and there could be no aggregation, so none. Now I will use a query which just use the group by clause. So I have already created this query because it would take a lot of time to type this. So this is the first combination with state and city. the grouping is based on this. Then we have grouping just based on state, and then just based on city. And finally, we have no aggregation. And once I run this query, you can see aggregations at different level. Let me sort it based on state. So you can see like these are state and city level aggregations, and this is just state level because this is null. Likewise, these are state level, and these are like city level, and this is when there is no aggregation based on state and city. So it takes the aggregated value of entire sales, which is 2175. And here you can see that the length of the query is quite huge. Imagine we have 3 combinations or 4 combinations. This would be quite lengthy, isn't it? So let me see the performance of this query. Let me check the query plan. And for 4 combinations, you can see here that it scans the table once here, and then this is second time, this third time, and finally it scans again here. So total 4 scans. Imagine if you have a very big table having billions of rows, all these 4 scans would be very costly, isn't it? Now we will see how we can rewrite this query and get the same output using grouping set. Let me open a new SQL script. And let me query the table. And let's filter based on country USA and group by grouping sets. So as you know, we have 4 combinations, so we will try with state and city. State, city, then state, then city, and finally nothing, none. And the output of this query, let me change the projection. State, city, and sum of sales amount has total sales. So the output of this query would be equivalent to the query which we have written here, which is quite lengthy and also has some performance issues. So let me run this. Cool. So if I sort it out, I can see there are 17 rows, same as here, and the total aggregation is 2175, which is same as here. Since it's a set, so the order is not important, and it's not able to sort this null value, but as you can see, the values, the entire result set is similar. So this is about grouping set, and you can see how easily we have achieved the same thing with a very succinct code. Let's quickly check the performance. And here you can see the scan is just 1. It means it's better in performance as well. So we have improved the code readability. We have reduced the operational overhead of this code, and also the performance is better. Let's try the same problem statement using cube subclause, and let me copy this query so that I don't need to type it again. And here, instead of this, I replace it with cube, and then I remove here, and that's it. So it's so very easy. And as you can see now, even this code or grouping set has been reduced to just a few letters. So if I run this query again, and I can see the same result set, 17. So in what scenarios we should use cube, and in what scenarios we should use grouping sets? So let me put it here like this. So let's say I have a requirement where I need to do grouping based on custom aggregation. So I just need like state, city, and state. I don't need city and none. So I simply can remove this from here and select the only sets which are really required. I can't do this using cube, because cube will generate aggregation based on all the combination. But if you have a requirement that where you need all the combinations and the number of columns are, say, greater than 3, then grouping set will be a bit cumbersome, because you have to write down all the combinations and you may miss, and verify it. It's quite time consuming. But in cube we just put, like, let's say country, state, city, and it will create all the 8 combinations of aggregations. So in those situations, cube is very handy, and the performance is similar to grouping sets. Now let's discuss quickly on the Rollup. So in Rollup, our Rollup assumes that there is a certain hierarchy amongst the column. So in this case, let's say state has cities, right? So there is a hierarchy here, and cities at a more granular level. So if I use a Rollup like this, it will generate combinations something like this, and this. Let's quickly validate. Select. So let me copy paste this again. And let me put Rollup, and let's run this query. Now here you can see that the number of records has been reduced from 17 to 11. It means some of the combinations of aggregation has been dropped. Let's see what has been dropped. So this is state and city combination, so which is present for California, and then state is also present. So if I drag this, oh yeah, so state and city is there, and then state, so state, and then this is none, so it's ignoring city, and then we have this none, so this part is there. And if I count the number of cities, so 1, 2, 3, 4, 5, 6, so those city combinations are missing. So if I subtract 17 minus 6, it gives me 11, which makes sense. So yeah, you have seen that with a very less line of code and with higher performance, how we can use these advanced features in our data analysis